TidierPlots.jl is 100% implementation of the R package ggplot2 in Julia, powered by Mackie.jl package. According to the documentation of the TidierPlots.jl, this package is an R user's love letter to data visualization in Julia. TidierPlots.jl has 3 goals that differentiates it from the other plotting packages in Julia programming language. First, it sticks as closely to the tidyverse syntax and behavior as possible. Second, stay as compatible as possible with Mackie.jl package, and also to extend ggplot with Julia-specific features where appropriate. Let's dive in and check out this amazing package. First of all, we have to install a couple of packages. The first one is the TidierPlots package, of course, and the other one is the dataframes package that we want to load some data and store it in an object. And the other one is Palmer Penguins, which is a package for actually having some dataset. It's a toy dataset that we can work on. Of course, you can install additional packages, but we don't need it. Now you just have to wait for the packages to be installed. After you see the message that the packages are installed successfully, you can go into the repo and type using TidierPlots and import the packages one by one to see whether they have been installed properly. Now I make a Julia file example.jl and I start coding. I type using TidierPlots and execute it by hitting Shift and Enter, and also using dataframes because we need the dataframes package. And the other one is using Palmer Penguins, which is a toy dataset that we import and try to show our examples with. To speed up the explanation, I paste the codes. So at the line 5, I define the penguins object, which is a data frame, and I use the drop missing function to actually drop the missing fields, and to actually plot the dataset, I use the ggplot function past the penguins object and use the @AES macro. AES is a set of optional aesthetics for the ggplots. If a set of aesthetics is specified in the initial ggplot call, these aesthetics apply to all layers added to the plot, unless they are overridden in subsequent layers. Basically, AES is used to map variables in your data to visual properties, aesthetics of the plot. These aesthetics can include things like position, XY coordinates, color, shape, size, and etc. Each aesthetic is a way of visualizing a variable or a statistical transformation of a variable. Aesthetics are specified in the form AES opening parenthesis aesthetic equal to variable closing parenthesis, where aesthetic is the name of the aesthetic and variable is the column name in your data that you want to map to the aesthetic. The variable names do not need to be preceded by a colon. GeoPoint function is used to create a scatter plot. It's typically used with aesthetics mapping variables to X and Y positions and optionally to other aesthetics like color, shape, and size. GeoPoint can be used to visualize the relationship between two continuous variables, or a continuous and a discrete variable. There are some visual features that can be changed within GeoPoint: shape, size, stroke color, and alpha. You should note that the alpha, or transparency, is set to a value between 0 and 1. This is such an amazing package. Everything seems so easy. Please let me know what you think about this package in the comment section down below the video. As you can see, I can change the theme to theme dark instead of theme minimal, and I get the darkish style, and it's really cool, but it needs a little bit of contrast. It might not be the best option over here. You can set labels and limits, and it's pretty obvious. geom_bar is used to create bar plots for categorical data. geom_col is a spatial case of geom_bar where the height of the bars is already computed and doesn't need to be counted. geom_histogram is used to create histogram, which is essentially a bar plot for continuous data where the data is divided into bins, and the number of data points in each bin is counted. geomLine is used to create line plots, and its syntax is pretty obvious. It's like the other examples, and you can just manipulate the plots and create line plots with that. And also there is another thing called geom_step, which creates a step plot, which is similar to line plot, but with a step pattern rather than a direct line from point to point. And geom_box creates a box plot, and again, the syntax is pretty similar. And you know, the most important thing and the essence of this package is that you can use anything and imagine anything, but with a simple line you can make it into reality, and that's super cool. I have also illustrated examples of geomViolin and geomTile. One of the pretty cool aspects of ggplot is you can use some or division operator or plus operator to actually subdivide the plots or make subplots basically. You can make subplots with simple operators, and it's pretty cool and handy, and it makes the syntax pretty short, and it is much more comfortable than the analogs in the other programming language. For example, in the matplotlib package, you have to create subplots, figure, and pass the objects around to make it work. Scale X continuous and scale Y continuous can apply labels and scales, reverse or adjust the text. This video was just about reviewing the package and making the other people know that such package exists, and it's pretty useful and it's amazing for data analysis and scientific computing or reporting your results, whatever the data that you have at your disposal. And hopefully you've learned something. And you can also save the plots with ggsave. You can specify different formats, for example, PNG or SVG, and it works. I mean, you just specify the format and it works. No headaches and no waste of time. That's super cool. Do not forget to like this video and subscribe to the channel to not lose future content on Julia programming language. As always, see you all later.